Hi Jill.
Hi Jack. What homework module are we going to explore?
Look at making our games have 3 levels of difficulty, and using the timer in conjunction with an audio file.
Yes, when you are good at winning in level 1, then we can make it harder in level 2 by having to throw the dice and get the exact score that will get you home to win the game.
Yes. This opens up the game, because the second player may have a chance of winning just when all chance seemed to be lost.
To make the game more frustrating, we can introduce gazumping into level 3.
Gazumping? What does that mean?
When the counter ends its move, and lands on another counter, then the other counter has to go back to the start, to begin all over again.
That will make the game last forever.
No, it won't. The chances of throwing the dice to get a score that will land the counter on another are about 6 to 1.
Is there anything else we can do to make it harder to win?
Yes. If a player throws a 6 in levels 1 and 2, the second dice rolls and the results are added together. But in level 3, when a 6 is thrown, the counter can move, and hopefully gazump another, before the second dice is rolled.
That is a lot of code to add to the program. It would be best to get level 1 working first before introducing any difficulties.
Let's start our program by hiding all the buttons, picture boxes, and labels, by setting their visible properties to false, except the label in the bottom right, which we use to display text that prompts the user to take some action or other. We play an audio file explaining how the game works at all the different levels. Whilst this is playing, we start the timer. When the audio mentions clicking one of the level buttons, it ends, and we set the timer to display the 3 level buttons, and the labels next to them.
By clicking a level button, you change the value of the integer variable that we call level, and we change the background color of all of the labels next to the buttons to black, and then the label next to the clicked button, we set to green, to indicate which button was clicked, and which level we are playing on.
We can have an audio file play. You have chosen level 1. Then we restart the timer. All the hidden controls are made visible. The timer sets its own enabled property to false and stops. The text in the bottom label is changed to player 1 to roll the dice, and an audio file plays, which instructs them to do the same. All variables are reset to 0 or false, if they're Boolean variables.
The dice rolling animation is performed when the roll dice button is clicked, which sets the variable I die 1 to 0 and I die 0 to the value of a generated random number.
As explained in the random numbers module,
we use the variable I turn to keep track of which counter is in play.
There are 3 ways of moving the counters. The first is to have a code block for each player, and the second is to have one block with an if I player equals 0, then move counter 1, and if I player equals 1, then we move counter 2. The if statement tells us which counter is in play. The location values of the counter are copied into the location values of a third hidden counter. The third counter is moved to the new location. The visible property of the player's counter is set to false, and the visible property of the third counter is set to true. When the move is over, we copy the location properties of the third counter into the location properties of the counter in play. We hide the third counter and make the counter in play visible again with another if statement.
The player's counter moves the number of squares equal to the score of the 2 dice added together. Unless you have decided to move the counter before rolling the second dice, the variables I direction 0 and I direction 1 holds the value of the timer select case position. This is a loop that moves the counter 1 square at a time by incrementing the across and down value of the counters by a set amount, depending on the size of the board game squares.
The dice score is reduced by 1 and a logic gate exits the loop, if it is 0. Code execution then goes to the end of the move code block to check which level the game is on and what action to take if the counter is home. In level 1, this means that the game is over. But in levels 2 and 3, the code execution goes to the code blocks that deals with moving the counter backwards. At the end of the move, the value of I direction must be changed to the value that will move the counter towards home again.
Otherwise the counter will end up going back towards the start and the game will crash.
If the level is 3, then the code checks to see if the other player is on the same square, and if they are gazumped and have to go back to start.
At the end of the code block, the text in the label is changed to indicate whose turn it is next. Code execution stops until the next player clicks the roll dice button, and the timer is activated from the beginning of the dice animation.
We could put the code loops in a sub, but they would run so fast that the counter would jump to the last square of its move in a blink of an eye. A short audio file of a beep could be played with its audio play mode set to wait till complete, which stops code execution until the sound file plays out. But this can be annoying, especially if the player's dice score is 12.
With a series of loops within a timer, the speed of execution can be changed when the code is running, or in the timer's property window. This is done by adding itick plus equals 1. A timer interval property of 100 should work fine if we put all our checks in separate case statements. We can change the value of case is equals to slow down code execution when the counter is moved.
If any of the direction sections contain a snake or a ladder, then we have to change the counter's location by using the timer in conjunction with a sound file, and change the value of I direction.
Boos for a snake and cheering for a ladder.
Well, that is all there is to it. Shall we do another module or go out to play?
Perhaps next time we could look at expanding the game so that more than 2 players can play. Or add scoring. Losing points when we land on a snake, and gaining when it's a ladder. For now, how about a game of softball in the park?